Thank you. Can you hear me okay? Yeah, there it goes. All right, so we're going to talk about N things that you don't know about the router. Why N? Because I'm not sure how much you all know about the router, so my hope is that you will leave this session with finding out at least one thing that you didn't know before or that you might not have thought about a particular way before. I have one slide on how the router works, just to ensure we're all on the same page with regard to the terminology, and then we're going to jump right into our N things. So how does routing work? And why do I have a weird thing in the middle of my screen? That's not me. Is that just a thing on the screen? Okay. Anyway, all right, hopefully you'll be able to see around that. So how does routing work? Well, frequently we have a toolbar or some kind of something around our application that allows the user to navigate around. Behind that, we might have something like this, a router link that identifies what path that we want the user to take when they click on that link. When the user does click on that, it changes our URL so that it has that path on it. The router recognizes, hey, we've got a new something on the path, and it goes and looks for a route configuration. So what Angular does is it takes any routes configured in your application and puts them in one combined list. So it has one merged list of all of our routes. And it starts at the top and finds the first match. So in this case, it'll find the path movies, know to load the component movie list component. So it loads that component, finds the associated template, loads and prepares that. Then it starts to look for an appropriate router outlet. So it finds a router outlet, and that's where it displays the component's template. So that's in one slide how the router works. Hopefully that was helpful for any newer developer, Angular people here in the audience. With that, we're going to launch right into our first of N things. To menu or not to menu? This is one of the questions that I get often. How do we deal with the fact that some of our pages we want to route with a menu on the top, and some of them, like our login page, we might not want to have our menu on the top. So how do we deal with that? Well, looking at our app component, HTML, we can see that we have our nav bar with our router links, and under it is our router outlet. So anything we route to that router outlet is going to have our menu on top. That's because we're telling it to do it that way. So how do we deal with not having it do that? What this will do is it will appear like this, where we've got our menu across the top, and then our app router outlet is the area underneath it. So how do we make it not do that? Well, one option is we could have some kind of global flag with an ng-conf, and then every component would need to turn that on or off. Now, as soon as we hear the word global, we should be thinking, right? We don't want to do that. So what would be another way to handle this? Well, we can change our app component from all of this to just that, so that our main app component is only the router outlet. Then our whole browser area is our app router outlet, and we can log things that we don't want the menu into that router outlet, so we can put our log in there. All right, but we still need our menu somewhere. So what we can do is we can create another component. I called mine shell component, and this is where we then have our router link. And now we have a second nested router outlet. So now we've defined a hierarchy of router outlets for our application. Now we can simplify this code even further by taking out our menu stuff, putting it into our own menu component, and then we end up with our shell component looking something like that with just our nested router outlet and a reference to our menu component. So then we have our app router outlet, which was the whole display underneath in our browser client area. We can route to that then our shell component, so our menu shows up. Then nested inside it, it has its own shell router outlet, and then we can route into there our movie list or our movie detail or our movie edit, anything that we would want to appear under the menu bar. Nested router outlets. Okay, well, so what does that look like in code? How do you actually make that work in code? In our route configuration, at the outermost level, anything at that level is going to go to our outermost level of our router outlets. So in this case, it will be our root app router outlet. Anything that we want to appear in the shell components router outlet, we define as children under the shell components. So that way it knows which level of the hierarchy to put them in. Okay, all right. So that's to menu or not to menu. Our next item is preventing partial page display. Now, when we, as developers, run our application, we frequently get really good performance, right? We're frequently running our servers on the same machine or even have test servers we're running. And we might not notice that when the users actually get the application, it shows up like this. So here's our detail page with the static text. A few moments later, finally, the data shows up. Okay, so our users might not want that kind of behavior. What are our options for dealing with that? Well, one of the options that some people like to use is a resolver. I kept calling this a reducer. I've been doing a lot of NGRX lately, calling it a reducer. That's not a reducer, it's a resolver. So if I accidentally say reducer, that's not what I mean. So a resolver service, and a resolver service implements resolve. You tell it the data you want to resolve. We're doing movie details, so I want a movie. I'm passing in my movie service. So what is a resolver? Why am I passing in the service? What am I really doing with this? Well, a resolver is part of routing, and what it does is it allows us to execute an asynchronous operation and have the routing wait for the completion of that asynchronous operation. So what we're going to be doing here is our HTTP calls, which of course are asynchronous operations. So I'm passing in my movie service because that's my data access service that does my HTTP requests. I go to my route to get my ID because this is a detail page, so I have to know which movie I'm displaying the detail for. And then I call this .movieservice.getMovie, and notice that I do not have a subscribe on there. The resolver will automatically subscribe for me, and then it will wait until the data is returned before it continues with the route. Because this is a service, we need to add it to the providers array. In our configuration, we add the resolve property to our configuration, specify a name and the class name, and that associates a resolver with a particular path in our component configuration. Then in our actual component, oh, did you want that again? You got it? Okay. In our actual component, then, we no longer need to use our service because our resolver already got the data. So in our ng-on-init, we can set our data property to this .route.snapshot.data and pass it the name. The name, again, was the name that we had specified in the routing module there. So notice that we now are treating our data as, from our component's point of view, like it's a synchronous operation. So what does that mean? That means that our template no longer needs ngIf at the top to deal with the fact that we might not have gotten our data yet. It doesn't need safe navigation operators and so on, because we will have retrieved the data before actually even navigating. Okay, so that's how we prevent partial page display, one of the ways to do it. But if you kind of think this through, the user still has to wait somewhere, right? So in our particular case, we have our list page that the user's clicking on. And what we're going to want to do to let the user know that we're waiting at this point is to display a spinner. So how do we display a spinner? Well, one easy way to do it is to use routing. We'll use routing events. So we can actually subscribe to router events. Now, in this case, I'm doing it from app component, which means that none of my other components need to know anything about this spinner. it will just automatically appear anytime that there is a delay in moving through the route. So check router event is a method that I wrote that does this. So if the event is a navigation start, it sets a local property to true. If it's end, cancel, or error, it sets that local property to false. Then in my app component HTML, remember this is the one that only had our router outlet on it. I use my ng-if and then whatever visual, this uses the old Bootstrap, but whatever visual that you want. And this will automatically appear anytime there's a delay in routing. So you'll get the spinner anytime that there's a wait. None of the other components need to know to do that. All right, what's going on? What if your routes don't work? So you've put your routing in and it's not working correctly. It's either not routing or it's not changing routes or something is going on. How do you debug these things? Well, you can set it up, and I know this might be hard to see because this is kind of little, but you can turn on routing such that you can see a trace of all of the routing events. So all the events I mentioned, navigation, start, and so on. If you can kind of see up in the front, I've got resolve start, and then I've got data there. That's my data access service going, logging its data retrieval, and you can see that that's happening before it actually completes the navigation. So how do you turn this on? In your app routing module, you just add enable tracing true. Okay, and that turns it on, and then after you've resolved whatever issue you might have with your routing, you can just set it back to false or delete that little bit again. All right, guards at the ready. One of the other things you might want to do with your routing is guard your routes. So you might want some routes that the user can only access if they're logged in, and if they're not logged in, have it pop up a login dialog or a login page. Other routes, you might want to prevent them from navigating away. Why would you ever want to prevent someone from navigating away? Well, say we have an edit page, such as the one shown here, and the user's just made a whole bunch of edits, and then they click back on the movie list, and we don't want them to lose their edits. So we could put up a little message saying, hey, do you really want to lose your edits? Or if we're pretty confident they meant to save those edits, we could auto-save them, or we could do whatever that we would want there. But we can capture that action. We build a guard service very similar to how we build our resolver service. We implement the name of the guard. So in this case, it's can deactivate. We could also do can activate, can load, and so on. Here I'm using the generic parameter to pass in the component that's being deactivated. The can deactivate can take in the component that's being deactivated. Now that's a really important point because since we're getting the component that's about to be deactivated, we can actually reference it. So we can ask the component, hey, do you have dirty data? So that we don't say to the user, hey, do you really want to save your changes? And the user's like, I didn't change anything. So that way we can check that, we can access its data, anything that we want. We return true from the method if we want the routing to just continue as normal. We return false if we want to cancel all of the future routing events for that particular route activation. Okay, because it's a service, we register the guard, and then again, we add it to our configuration by specifying another property, which is the name of the guard, so can deactivate in our case, and then give it the class name of the guard service that we write. Okay, so that's how we do guards. Keep constant. Now this one, a lot of people probably already know about because a lot of examples already show how to do this. Here, this is intentionally meant to be difficult to read. The point here is that this is difficult to read now because we have all of our route stuff actually kind of connected in to our ng module decorator. And that makes it hard to read. It makes it hard to read the decorator because there's so much other stuff in there. So the idea is we're going to pull that stuff out of there, and we're going to put it into a constant at the, in our class file. So there's the definition of the constant. And you can see now that's much easier to read. You also can see that I've added a few more. I added a second level of router outlet here. So now I have two sets of children, one that's going to route into the shell component and another further down that's going to route into the movie edit component. That allows me to have a tabbed edit dialog, as you might have noticed on the prior slides. Okay, so then our ng module decorator looks much simpler. We just define our constant there, and that makes that easier to read and work with as well. Okay, it's a feature. Now, we've all been taught that we don't put all of our code in one code file. We don't put all of our Angular application in one Angular module. I went hiking in Moab right before I came, and I've been sneezing ever since. I feel like I'm about to sneeze. Anyway, I'll try not to do it in the mic. So it's a feature. So what about feature module? So here we have our constant, and we really want to take our movie stuff out of there because it doesn't belong in there. It should be in a feature module instead. So what do? Cut, paste, not too difficult. Then I do router module for child and pass in my constant. But it won't work. And you're like, what? I know that works. I do that every day. What are you talking about? Absolutely, that works. I put that in my code. In our particular example, this will not work. Why won't it work? Well, somewhere in our application, as soon as we decide we want feature modules, we have to pull that feature module in. So somewhere we're going to have an import, so we're going to import our movie module into our app module or into our app routing module, or however our standards define where this should be imported. What that's telling Angular to do is to merge our routes. Remember I said at the very beginning that Angular takes all of our routes and makes one big list of route configurations and then goes through top to bottom? So what this guy's going to do is it's going to merge our routes. So we're going to have our movies routes first, because we specified it first there, and then it's going to have our other routes. Where is our movie list component going to route to now at this point? Which router outlet's going to show up? Is it going to show up in? It's on the outermost set of our configuration. So our movie list route, our movie list component, our movie detail component, our movie edit component are going to show up without the menu. Is that making sense, what this is doing? Because where we really want that is right there. How do we get that right there? Well, there are numerous ways to handle it. The easiest way to handle it is lazy loading, and we should be doing lazy loading anyway. So let's talk about that. I like to represent lazy loading with this image. And the reason is sometimes we think of lazy like a lazy Sunday afternoon in a hammock with our favorite beverage. But really, lazy is more like this guy. He's being lazy right now, but he's really super fast. We know when we build our applications, it's going to build it into a bundle. And if we aren't using lazy loading, it's going to be one big bundle. And when the user accesses our app, they have to wait for that whole big bundle to come down to their machine to get processed by the browser before that first page will appear. So what we want to do with our feature modules is we want to make them lazy loaded. So when we build our application, it will actually bundle each feature, each lazy loaded feature, into its own bundle. Okay? That means when the user first hits the application, only the little app module needs to come down. The other modules then can come down asynchronously in the background, or they can come down on demand, depending upon how you have your lazy loading set up. So how do we set up lazy loading? Well, what we do, I'm going to go back for a moment. If you look at these, all of our paths start with the prefix movies. Movies, 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 edit, movies, ID, and so on. So what we're going to do here is we're going to pull that movies path off, specify it, and notice here we're right in the correct place, right under our shell component as part of the children. And we're going to specify load children, which is telling it to do lazy loading, and we give it a string. The reason we give it a string is because we do not want any references to our movie module in our app component anymore, in our app module, anywhere in our main bundle, because we don't want the build process to pull in the movie module as part of our first initial app module. In the string, we specify the path, and we give it a hash and then the name of the class. So our class was called movie module. Thank you. Then, now we have our routes. Notice that the paths no longer contain movies because we had pulled that part off, and now our router module for child will work because this tells it exactly where to put them. And that's it. So, did anyone have at least one of those N things that they didn't know or hadn't thought about quite the same before? Yay! Okay, so for more information, you can reach out to me on Twitter. The code, the full code for the sample application that goes with this, you can get off my GitHub. My slides are here, and I also have a course on Pluralsight Angular routing that you can find there. I have free cards for a month on Pluralsight if you don't have a Pluralsight membership. And with that, I want to thank you all very much.